Siemens presents the new generation of KNXnetIP Secure products. In this web-based training, the topic KNX Secure and its background will be presented in a short introduction. Next, the functionality of the Siemens Gamma KNX IP Secure products will be explained. The third section deals with project planning and commissioning with ETS. Finally, there is a chapter containing a number of important notes. Introduction. What is KNX Secure and why has it been introduced? Motivation. Since the beginning of the millennium, networking via IP networks has also become increasingly established in building automation. The reasons for this are the constantly increasing amounts of data that have to be processed today in order to operate buildings efficiently, and the integration of many trades into a higher-level building control system. The KNX system was involved in this development right from the start, as shown by the Siemens Gamma Instabus IP router N14601. Launched on the market in 2004. This networking, however, also gave rise to new threat scenarios. Attackers can now manipulate building technology both locally via the technical bus networks and globally from the Internet to pursue their criminal goals. This applies to all types of buildings, and whether functional or residential is completely irrelevant. In particular, the smart home or smart building hype of recent years has led to many systems today being equipped with remote access options, often without any protection against unauthorized access. But an attacker can also gain access to the system within or near intelligent buildings if one considers the local cable or wireless networks, which are usually still completely unprotected. Additionally, there is often no separate network set up for building technology, which further increases the possibilities for manipulation. If the appropriate specialist knowledge is available, it could even happen that someone connects to the twisted pair KNX bus line directly in order to abuse the system from there. KNX bus lines are often required outside buildings, for example, for motion detectors or weather stations. KNX Secure has therefore been developed to provide the right answers to these current and future cybersecurity challenges in building automation. Characteristics of KNX Secure. KNX Secure provides two different methods for secure KNX communication at Internet Protocol, IP level, and Twisted Pair, TP level. KNX IP Secure, secure communication via IP telegrams. KNX IP Secure means that all KNX communication is encrypted via the IP network, both via multicast for KNX IP Routing Secure and via unicast for KNX IP Tunneling Secure. This eliminates the need to set up a virtual private network or VPN tunnel for secure remote access for commissioning and diagnostics of KNX devices. KNX Data Secure, secure communication via TP telegrams. KNX Data Secure describes the transmission of KNX telegrams that are transmitted on the twisted pair or TP medium. This is also referred to as end-to-end encryption. With KNX Data Secure, a decision must be made for each individual group address as to whether it should be transmitted secure or non-secure. The application devices must support this type of communication, and also each must have a factory default setup key, or an FDSK. The setup of KNX Data Secure and KNX IP Secure runs separately, but the following applies. An IP router secure is always able to forward or route KNX Data Secure telegrams. It must encrypt them in the same way as all non-secure telegrams according to the rules for KNX IP Secure, when it forwards them to IP and decrypts them again when they are transferred from the IP network to the TP line. The KNX Data Secure encryption is then only removed from the end device. Thus, KNX Data Secure telegrams over IP are double secure. The KNX Secure standard. What does it comprise of? In order to move from open communication that can be understood by everyone to secure communication, proven methods of communication technology are used. Authentication. The bus telegram is sent with an additional code, a so-called authentication code. This authentication is defined during commissioning and ensures that only known devices transmit KNX telegrams. Sequence counter. Authentication alone is not sufficient. The telegram could, for example, be intercepted and repeated. Therefore, the code also contains, encrypted, a so-called sequence counter, the current status of which only sender and receiver can know. Encryption. The third technique is the actual content encryption. The user data contained in the telegram is encrypted. The user data can no longer be read and evaluated in plain text. Application to KNX Secure. All three methods described are used for both KNX IP Secure and KNX Data Secure. Many thanks for watching. Next, find out which features Siemens IP Secure products have.